So if you watch my other video, you'll know that I talked about potentially designing this new board to replace it. Just to have a new board, better traces, thicker technology is better. Remove unnecessary holes, like see here, these two aren't even used for anything. Same thing on this side, these two are not used for anything. And then also, once I get alignment, which I'm almost finished, yeah, this is a piece of paper. It's a template, just I'm ensuring that I did my measurements right. Then I will send it to the service and they will print it for me. Now, I designed this in this program called KiCad. You can download that for free. It's available for all major platforms, Linux, Mac, Windows, maybe others, I don't know. It's open source, completely free for personal use, hobby use, commercial use. They don't care. It's free. You don't have to pay any licensing fees, nothing. Which I like. The learning curve is steep. I didn't find many good videos online for beginners at all. I was a little bit frustrated. So I actually use AI. I said, how do I outline a circuit board? And how do I make traces? And how do I, all this kind of, and to a point where now I'm at a point where I don't ask any questions. I just kind of know what to do, at least for what I did here. There's probably some new things I have to learn. So I'm not finished. So basically, this is the design, right? And if you want to see how the circuit is going to look, you can use this 3D preview viewer. So this is how it looks. And it has these, you can turn it around. Do whatever stuff. And more importantly, even that, you can print it on paper using 1/1 scale, which I believe, unless I'm wrong, this is going to be the actual scale of this printer and PCB board. And so that's where we are here. I want to ensure, first and foremost, that this fits over the existing bolts that bolt on to the capacitors. These two fit. These two I need to move a little bit, 1 millimeter, a little bit, because you can kind of tell it's not perfectly aligned. So I'm gonna move it in software just a little bit, realign it. Now notice that we have a lot of extra space here all around it. We're not, the circuit board, if we want to expand the edge a little bit, we can. See this circuit board, they put the traces almost at the very edge of the circuit board. This isn't very good. This is not good design, actually. I just learned this in the software. So that's the first thing. Although, we'll give him slack since this was 1980s. The second thing is, once I have alignment, which I almost had, I'll make this tweak, reprint this and realign it. I wanted to see if there's any additional improvements on this. So the first thing is, I'm going to remove any holes that don't need to be here. This will be removed, this will be removed, this will be removed, and this will be removed. Okay, let's look at this thing. This is the main power cable coming from the transformer from one of the primaries. And also there's one here. This carries lots of juice and just connects these 2 points. And same thing here, just this transfer point to the rectifier. The rectifier are these 4 points, the rectifier bridge. And then the rectifier bridge comes off here and comes up there, does its thing. But the thing is, like, a lot of juice comes through here. This is a very small island, trace island. So what I'm doing now is I'm actually going to reduce this a little bit, going like here, like so, and then expand this, which I think I did in this guy already. Yeah, see how bigger it is? And I did the same thing here to this island. Is a little bit bigger. No reason why it can't be, really. And I think it'd be better for the circuit board. So that's the first. And I'm not yet 100% finished with this, so I do have some degrees of freedom. I'll transfer this. I have to actually learn to do this. I'll transfer these writings here. I'll mimic them. And then I have to make the holes. I have to put holes in it. I'm not gonna I'm gonna not put the holes so much on the very edges like they did here. Again, improvements. Because when you look at this board, or all it has on the other side is the rectifier bridge, fuses, and some lead connectors here and here, and that's it. The rest of the board is bare. There is no components here. It's kind of bare and just wires. So, you know, the wires, these don't need to be aligned correctly as long as the right islands are connected. There's no reason like for this thing to be at the very edge. We can make this a bit better. Same thing here. We can connect them maybe off a little bit in the corner. You know, just some improvements. So I'm gonna apply those to this prototype, and then when I feel like it's looking good, I'm gonna send it to the service I haven't made, and then we'll have another video of me actually receiving the boards and looking over them, quality of them, and we'll actually install it. You know, I'll show you the new boards. Of course, I'm keeping the old equipment. I'm gonna throw it away. The old capacitors I kept, the old bridges I kept, these will keep. But this is a good software because you might come across some amp that you really like and has old circuit boards or old cracks and lifting, the edges are lifting. You can kind of see some of this is already happening here. See these edges? They're lifting. And then this whole edge is lifting. This isn't much of a big deal because, you know, these are fairly big islands, so, and this still conducts. It's not like it's not doing its job, but it's just not nice to see that. Make these bigger. Yeah, I'll transfer over the writings as well, V- and V+ and whatever. And then once it's finished, it's finished. And I think this one says ground here. So I'll put this to the side actually. So it looks nicer. I'll put the ground label like here. So actually read it. Kind of like to the side like these. You can read. You can't see shit here. Of course, it will have my logo and the date when I designed this. Not so much the manufacturer date, but the designer date. And then as far as the printed circuit board will probably not be off by far. Once I send it in, there'll be just maybe a week off from the design date to the manufacturer date, so it's not a concern of mine. Yeah, I really like this amp, and I wanted to do this. Well, not just to do it, to learn it, because then I can apply it in any other situation, just like I talked about. It's good to know because. Yes, so as far now, I always enjoy tinkering stuff like this. This is not a waste of time for me. Okay, you might think it is, but it's a passion of mine, like one of many things I'm interested in. So I really like this, and now I've learned it. You know, it's not going to be painstaking for me anymore because I know how this works, kind of, and then I can go from there if I ever want to design something. One of the things I actually want to design possibly was an open source amplifier, like a circuit board with components and everything, and be open source so people can tweak it, do whatever they want with it, or just use as is. Be a kit form, of course. It's just something I always want to do. I know there's kits out there, but it's be my own personal kit, and it will. Yes, that I want it to be good, of course, good, right, sounding and all that. But it'd be probably like a lower wattage amp, like 30 watts or 45 watts, something like that. It's not going to be, for the first project, I'm going to keep a low wattage just to see what I can do. But it will sound good for what it will be designed for. This is just one of my ideas in the future. Gotta have some goals, right? Something inspirational to look towards. Anyway, I'm going to do what I just did. And then we'll go from there. Cheers.